All right, so let's do a couple more examples to make sure that we're comfortable with adding and subtracting these radicals. So our next example here, we have the square root of 12 plus 3 square roots of 27. So I'm going to break up the square root of 12 as the square root of 4 and the square root of 3. Now the cool thing about these problems with adding and subtracting radicals is that we get ourselves some hints on the simplifying aspect of things. So of course my 3 is going to copy down, but as I'm looking at 27, if I'm going to have like radicals, then they're both going to have a root 3 in them. So that kind of gives me a hint that it must be 3 times 9. This isn't always going to work, but it's a great place to start. Now once we do this, now we can do the take the radical step, which gets us 2 square root 3 plus 3 times root 3. Now we do the clean it up step. 3 times 3 is 9. That's part of my clean it up step. Now that I'm done with the 3 steps of simplify, now this is just that easy idea of combining like terms. Those are both root 3's. 9 plus 2 is 11. So this is just 11 root 3. So let's look at the next example. Cube roots and the numbers are getting a little bigger. But again, if we use that same idea of a trick, it's not a guarantee. But if these guys are like terms, they're going to have cubed root 2's in them. So as I try to do the break it up step with 54, if I had to guess, I'd say I'm probably going to be left with a 2. And sure enough, if I did that, I'd be left with 27, which is a perfect cube. So if I did the same thing with the 16, said, hey, maybe he's a 2 as well, it'd be 2 times 8. And 8 is a perfect cube. Now the other thing that I would do on these problems is I've got that plus cube root 2 at the end. I'd actually write his coefficient of 1 if I were you. It might help. So we've got the cubed root of 27 is 3 in our take the radical step. Cubed root of 8 is 2. Now in the clean it up step, it's a small clean it up step, but we'll go ahead and do it anyhow. 5 times 2 is 10. So now all 3 of these are cube root 2's. So now I just want to look at my coefficients. 3 minus 10 is negative 7. Negative 7 plus the 1 is negative 6. Cube root 2. Let's go ahead and do one that's got some variables in it. We're still going to do the same thing as far as break it up, take the radical, clean it up. We're going to break up 48 as 8 and 6. We're going to break up y to the 4th as y cubed and y to the 1st. And then we're going to look at the second guy. Cubed root 6 doesn't simplify, but the cubed root of y to the 4th, I could break that up as y cubed and y. There's my break it up step. Now let's take the radical. Cubed root of 8 is 2. Cubed root of y cubed is y. Everybody else just copies down. We've got cubed root of 6 and cubed root of y. We've got the cubed root of 6, cubed root of y. And now let's clean it up. Now in the clean it up step, we're going to clean up everything to the left of the plus, and then we'll clean up everything to the right of the plus. So keep in mind each of those are their own individual terms, and so they get cleaned up independently of one another. So for the highlighted yellow one, the stuff outside the radical is 2 times y. Inside the radical, I have a cubed root of 6 and a cubed root y, so we can write that as cubed root 6y. Now for the stuff underlined in teal, outside the radical, I have a y. I'm going to write 1y because, again, it helps sometimes when we're talking about coefficients to explicitly write that 1. Now I want to say, do we have like radicals? I have y cubed root 6y. I have y cubed root 6y. Those are the same. So I'm going to add my coefficients of 2 and 1 together to get 3. Y cubed root 6y. And that's my final answer.